Welcome to Lucid Mind Chemistry channel. In this video, I'll be solving Chemistry A-Levels multiple choice questions. Paper 13 from May-June 2022. For question timestamps and other useful information, please visit video description. Question number 1. Which atom has exactly 3 unpaired electrons in the ground state? They have given an isolated gaseous aluminum atom, similar carbon atom, a chromium atom, and a phosphorus atom. Let's first find out the atomic numbers. From then we can find out number of electrons and do electronic configuration. So we have aluminum, the atomic number is 13. So it is 1s2, 2s2, 2p6, 3s2, and in 3p we just have 1 electron. So unpaired electron is just 1. All other electrons are paired, so it is not A. Let's look into B. We have an isolated gaseous carbon atom. So carbon is 6. So 1s2, 2s2, 2p2. Now p orbital, it contains 3 x's, 2px, 2py, and 2pz. So first you have to put electrons in unpaired form and then you are going to start pairing. So we have 2 unpaired electrons in carbon atom, but we need 3, so it is wrong. Third one is chromium. The atomic number of chromium is 24. Electronic configuration of chromium should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. But we know according to rule, the d orbital, it is more stable when it has half filled electrons, which means the electrons should be 5 instead of 4. So it is incorrect. It should be like this: 4s1, one electron will shift from s orbital to d orbital, and 3d5. Now we can see we have 1 unpaired electron in s orbital. Let's see how many unpaired electrons are in d orbital. So we have 5, 3d, it has 5 x's, 3dxy, 3dyz, 3dxz, 3dx square y square, and 3dz square. So 5 orientation of d orbitals in which we have 5 electrons. So each electron must be unpaired first. So 1, 2, 3, 4, 5. So we have more electrons than 3 unpaired ones. So this one is also wrong. Part D, we have phosphorus. The atomic number of phosphorus is 15. So let's do this one. 1s2, 2s2, 2p6, 3s2, 3p3. Now p orbital has 3 x's, 3px, 3py, 3pz. Each can have maximum of 2 electrons. Now we have 3 electrons in total, so 1, 2, 3, 3 unpaired electron will be there. So only phosphorus has got 3 unpaired electrons in ground state, so answer is D. Question number 2. Which element has the second smallest atomic radius in its group and second highest electrical conductivity in its period? We have boron, calcium, magnesium, and sodium. We can look in the periodic table. We have magnesium, we have calcium, we have sodium, and we have boron. Now this represents group number. So we have group 1 which contains sodium, then in group 2 magnesium and calcium are present, while in group 3 boron is present. This represents period. So this is period 1, this is period 2, period 3, and period 4. Now we know down the group what happens: the number of shells increase and size of element increases. So now it says which element has second smallest atomic radius in its group. Now the smallest one will be the one that is on the top. So these two will be the smallest ones in group 1 and group 2, and sodium would be the second smallest because it is larger than lithium, so it could be sodium. Similarly, for second group, beryllium is the smallest, then we have second smallest, which is magnesium. Now boron is at the top of its group, so therefore this one is the first smallest one, not the second one, so this is incorrect. Similarly, calcium is the third smallest one, so this is also wrong. So we only have two options, either sodium or magnesium. Now second thing is the electrical conductivity. As we know, when we move along the period in metals, electrical conductivity increases. Electrical conductivity depends on the number of electrons that are easily lost. Now sodium has got one electron in its outermost shell and it can lose one electron to form Na+1, while magnesium can lose two electrons to form Mg2+. So therefore magnesium has got more electrons in the conduction shell, so therefore magnesium is better conductor as compared to sodium. So correct answer should be C. Question number 3. Analysis of hormone thyroxine gives the results as shown. Heating 0.5 grams of thyroxine with aqueous silver nitrate produces 0.604 grams of silver iodide. All of the iodine in thyroxine sample is converted to silver iodide. Then we have another reaction. It says complete combustion of 0.5 grams. It is similar mass of thyroxine produces this much CO2 and this much nitrogen. Measured under room conditions, which molecular formula of thyroxine agrees with these values? They have given 4 different formulas and we have different molecular masses. Let's start with the first one. In first one we have 4 iodine. So now we can write balanced equation with silver nitrate. So we have C15, H11, NO4, I4. From silver nitrate we have silver ions that will form silver iodide. So as it says, all of the iodine is converted, so all of these iodine is converted with silver to AgI. Now we are not concerned with the other products. Let's see if we can balance this. So now as we have 4 iodine, we can write 4 with AgI, so it will become 4Ag positive. Mass of thyroxine is given, it is 0.5 grams. Mass of silver iodide is also given, it is 0.604 grams. Let's first convert this mass into moles. We have molecular mass, so we know moles equals mass in grams divided by mR. So 0.5 grams of thyroxine divided by 776.6. The number of moles, it comes equal to 0.000643. Now according to balanced equation, we can see we have 1 mole of thyroxine that forms 4 moles of silver iodide. So if we have this much moles of thyroxine, then how much silver iodide is going to be formed? You can cross multiply or simply multiply with 4 because it is 1:4. So the number of moles of silver iodide will be 0.000643 into 4. So it is 0.00257 moles. So this much moles of silver iodide is produced by reacting 0.5 grams of thyroxine with silver nitrate. Let's find out if the mass is correct. So we can now convert this moles back into mass by using formula. So mass in grams equals moles into mR. We have moles 0.00257. Now finding molecular mass of silver iodide. We have silver is equal to 107.9, while iodine it is equal to 126.9. So together the molecular mass, it comes equal to 234.8. So now we can multiply this with 234.8. So mass in grams of silver iodide that is formed, it is equal to 0.604 grams. So this value is exactly similar to the one given in question. So we can say that A could be correct. Now let's move to second reaction in which complete combustion occurs. 0.5 grams of thyroxine produces this much CO2 and this much nitrogen. So now we can write another equation. We have C15 H11 NO4 I4. So CO2 and nitrogen is formed. So we are only concerned with CO2 and nitrogen. Let's balance this equation. We have 15 carbon atoms on the reactant side, so we can write 15 with CO2. We have 1 nitrogen on the reactant side, so we can make this 1 by using 0.5. So 1 mole of this produces 15 moles of this and 0.5 moles of nitrogen. We already know number of moles of thyroxine, 0.000643. So if it is 0.000643, then this should be 15 times of this one. So 0.000643 into 15, and this should be half of this one. So 0.000643 into 0.5. Let's find the number of moles and then we can convert those moles into volume. So by calculation, it comes equal to 0.009657. And this one, it is equal to 0.003219. Now let's convert these moles into volumes. As we know, 1 mole is always equal to 24 decimeter cube. In this one we need centimeter cube, so we can multiply it with 24,000 to convert to centimeter cube. Now the volumes of CO2 is 231.7 centimeter cube, while that of nitrogen is 7.72 centimeter cube. So it is almost equal to the given value. So therefore second option or second reaction is also correct for part A. So part A should be the answer. Question number 4. How many moles of oxygen are needed to burn 1 mole of ethane if the products of reaction are water and carbon only? Let's write balanced equation for this one. We have ethane is C2H6. It combusts in the presence of oxygen to form 2 products. One is water, one is carbon. So we have carbon plus H2O. Let's balance this equation. We have 2 carbon atoms, so we can write 2 with C. We have 6 hydrogen atoms, so we can write 3 with H2. Now we have 3 oxygen atoms on this side and 2 on this side, so we can write 3 by 2, or you can also use 1.5. So we can say that 1 mole of C2H6, it requires 1.5 moles of oxygen for this type of combustion. So correct answer should be 1.5 moles. Question number 5. Which compound has the smallest difference in electronegativity between its 2 elements? So they have given potassium fluoride, potassium bromide, so potassium is same. Then they have given lithium fluoride and lithium bromide. So we have fluoride, bromide, lithium and potassium. Let's see in periodic table. Potassium and lithium both are metals and both are present in group 1 of the periodic table. Lithium is on top, then we have sodium, then we have potassium. While halogens, they are present in group 7 or group 17 of the periodic table. Now in this one, fluorine is at the top, then we have chlorine, then we have bromine. Now, electronegativity is directly proportional to the number of protons and inversely proportional to the size of atom. As we know, down the group, size increases, so electronegativity decreases. Along the period, size decreases, electronegativity increases. So group 7 would have more electronegativity as compared to group 1, and in group 1 lithium would have more electronegativity as compared to potassium. So let's suppose if the value of potassium in electronegativity is taken as 1, then lithium should be 2 because it is smaller in size. And then along the period the electronegativity increases. So now for fluorine we know the maximum, it has got the maximum value of electronegativity, which is 4, and down the group size increases, so electronegativity will decrease. So for bromine we can say, let's suppose it is 3. Now we can find out the difference, and the one that has the smallest difference would be your answer. For example, for potassium fluoride K and F, the difference is 4 minus 1, which equals 3. While for KBr we have 3 and 1, the difference is equal to 2. For lithium fluoride the difference is 4 minus 2 equals to 2. And for the last one, lithium bromide, the difference is 3 minus 2, which is equal to 1. So the smallest difference between two elements is in lithium bromide. Question number 6. Whisper theory should be used to answer this question. Hydrazine has the following structure. This is the structure of hydrazine. What is predicted bond angle X? Now let's see what is here. We do have nitrogen. Nitrogen belongs to 5th group of the periodic table. It makes 3 single covalent bonds and a lone pair of electron is still present. So we have to look out for similar molecule or similar compound that is having nitrogen with 3 single covalent bonds and a lone pair. If you remember, ammonia is like this. We have 3 single covalent bonds and a lone pair of electrons. Now lone pair occupies more space, so the bond angle decreases from tetrahedral 109 to 107 degrees. So as this compound has similar structure, we have 1 lone pair and 3 single covalent bonds, so therefore the bond angle should be similar to that of ammonia, 107. Question 7. This question is about Buckminster fullerene, graphite, iodine and diamond. How many of these substances have simple molecular structure? Now we have 2 types of compounds. One are giant molecular or giant covalent, and second one are simple covalent. Now in all these 4 we have covalent bonding that is present. Buckminster fullerene could have formula up to 60 carbon atoms, and it is a football like structure. Second one is graphite. In graphite we have layers of carbon atoms and it is giant molecular, as we have a lot of carbon atoms and a lot of bonds are present. Third one is iodine. Iodine can exist in the form of I2 or I8. This one is simple molecular, as we have less number of atoms present in one of the molecule, and intermolecular forces are present between molecules to make it solid. And last one is diamond. In diamond we have carbon atoms in tetrahedral structure. Each carbon is bonded to 4 other carbon atoms, and this structure continues. So diamond is also giant covalent. So among these, the simple covalent or simple molecular structure would be of Buckminster fullerene and iodine only. So correct answer should be C. Question number 8. A student reacts 1 mole of magnesium powder in a sealed 0.030 meter cube container of oxygen at a pressure of 2 exponential 5 pascals and temperature of 600 Kelvin. The magnesium reacts completely to form MgO. What percentage of the oxygen will be used up? So let's see how much oxygen is used up and how much oxygen was present in total. We have a container of oxygen that contains this much volume, this much temperature, this much pressure. So let's first find the number of moles of oxygen that were actually present. So we can use ideal gas equation, PV equals to nRT. Now we need to find out the number of moles, so N is equal to PV divided by R into T. Now putting values, pressure is in Pascal, so it is 2 exponential 5. Volume is in meter cube, it is already given in meter cube, 0.03. R is ideal gas constant, the value is 8.31. Temperature should be in Kelvin, it is already in Kelvin, so we have 600. So now number of moles of oxygen, it comes equal to 1.203 moles. So this represents the total moles of oxygen. Now let's see how many moles of oxygen can react with 1 mole of magnesium powder to combust this one. We have the equation Mg plus oxygen, it forms MgO. Let's first balance this one. We have 2 oxygen, so we can write 2 and we can write 2 with magnesium. So it means 2 moles of magnesium require 1 mole of oxygen. As we have 1 mole of magnesium powder, so it will require half moles of oxygen according to this ratio. So 0.5 moles of oxygen is required or is consumed. This is the total moles of oxygen. Now we have to find out the percentage of oxygen that is used up. So this much is used up. Let's find percentage. So we can use formula percentage consumed. It is equal to number of moles reacted divided by total number of moles into 100. So simply putting values, we have 0.5 moles that are reacted out of 1.203 moles into 100. This will give us the percentage. So it comes equal to 41.56%. So our answer is nearer to 42%, so it is C. Question number 9. Which equation represents an enthalpy change, that is the average bond energy of the CH bond in methane? Okay, let's see what is methane. Methane is CH4. In methane we have 1 carbon atom, we have 4 hydrogen atoms. Now let's look at the number of bonds. In methane we have 4 CH bonds, and 1 carbon and 4 hydrogens. So if we want to find out the average bond energy of single CH bond, we have to divide this with 4. So we can divide the reactant with 4, it will be 1 over 4. Then we also have to divide the products with 4. So it comes equal to 1 over 4 CH4. That forms 1 over 4 carbon, and 4 by 4 is 1, so just hydrogen. So this is the equation that represents average bond energy of CH bond in methane. Now methane is in gaseous form. When it is converted to atoms, those atoms are also considered as gases. So the correct equation is given in part B. Question number 10. Magnesium carbonate decomposes when heated in Bunsen burner flame. Values for standard enthalpy of formation delta HF of the species involved are shown. We have delta HF of magnesium carbonate, delta HF of magnesium oxide and of CO2. All are given. What is the standard enthalpy change for decomposition of magnesium carbonate? So let's draw a cycle and then we can use Hess's law to find out the values. So we have magnesium carbonate MgCO3. We have to find out the decomposition. So decomposition of magnesium carbonate, it forms magnesium oxide along with CO2. Now the equation is already balanced. This enthalpy change is, let's suppose it is decomposition, del H dEc. Now the elements that are used up in this compound, we have magnesium, we have carbon, we have oxygen. So now they can react together to form this, or they can react together to form either of this compound. So this will show us the enthalpy change of formation of magnesium carbonate. So del HF MgCO3, while this part will show us the formation of MgO and the formation of CO2. Now by using Hess's law, we know both arrows, they start from this end, so 2 steps is equal to 1 step. Or we can find out the formula del H decomposition plus del H formation of magnesium carbonate. It is equal to del H formation of MgO and del H formation of CO2. So let's put values from the given table. Now we have del H decomposition. Formation of magnesium carbonate is minus 1095.8. Formation of MgO is minus 601.7. CO2 is minus 393.5. So del H decomposition will be equal to minus 601.7 minus 393.5 plus 1095.8. So it comes equal to 100.6 and it is positive. So in given answers, correct answer should be A. Question 11. Ammonium nitrate decomposes into N2O and H2O on heating. Which statements are correct? First one is that the ammonium ion is behaving as a reducing agent. The nitrate ion is behaving as an oxidizing agent. It is a redox reaction or it is a disproportionation reaction. Now let's see which ion is getting what. So we have ammonium nitrate. Ammonium nitrate contains ammonium ions and nitrate ions. It goes to N2O and H2O. Let's find out the oxidation state of nitrogen in NH4 plus in nitrate in N2O. In NH4 plus we have 1 nitrogen, we have 4 hydrogen, overall charge is plus 1. So nitrogen plus 4 equals plus 1 or nitrogen is minus 3. Now in nitrate, we have 1 nitrogen, we have 3 oxygen, overall charge is -1. So nitrogen minus 6 equals -1, or nitrogen is equal to +5. In N2O, we have 2 nitrogen atoms, 1 oxygen atoms, and overall charge is 0. So 2 nitrogen minus 2 equals 0, or 2 nitrogen equals +2, and 1 nitrogen will be equal to +1. Now we can see nitrogen goes from -3 to +1. It is therefore increase in oxidation state, so this is oxidation. In second one, nitrogen goes from +5 to +1. This is decrease in oxidation state, so it is reduction. The substance that is oxidized is actually a reducing agent, and the substance that is reduced is actually an oxidizing agent. So we can see ammonium ion is behaving as a reducing agent. Itself it is oxidized and it reduces nitrate, so this part is true. Nitrate is behaving as an oxidizing agent. It oxidizes ammonium to N2O and itself is reduced. Third one, it says it is a redox reaction. Redox reaction is the one in which both reduction and oxidation takes place. So oxidation and reduction both are occurring, so therefore this is also correct. Part 4, it is a disproportionation reaction. Now in disproportionation we have single atom that is oxidized as well as reduced, but in this one two atoms are actually getting oxidized and reduced. It is not a single atom, so therefore this one is wrong. All other 3 options are correct, so therefore answer should be B. Question 12. A student adds 3 moles of acidified potassium dichromate to an excess of iodide ions. The chromium is all reduced to Cr3+, and iodide ions are oxidized to iodine. The iodine released is reduced back to iodide by X moles of S2O32 negative. 1 mole of iodine is reduced by 2 moles of S2O32 negative ions. Find out the value of X, this one. Let's find out oxidation state of chromium. We have 7 oxygen, so it is -14. We have 2 potassium, so it is +2. In order to balance the charges, chromium should be +12. So if 2 chromium is +12, it means 1 chromium is +6. Now it says we have 3 moles of acidified potassium dichromate. Let's suppose if we have 1 mole of K2Cr2O7, it will form 2 moles of potassium K positive, as we have 2K, 2 moles of Cr which is +6, and 7 moles of oxygen which is O2 negative. But it says we have 3 moles of acidified potassium dichromate. So if we have 3 moles, then everything will be multiplied with 3. Now we have 6 moles of K positive, 6 moles of Cr6+, and 21 moles of O2 negative. Now we can use this value, as in the question it says that it is added to excess of iodide. So one reactant is this, second reactant is iodide, so we can say 6 moles of Cr+6, it reacts with iodide. The chromium is all reduced to Cr3+, so it goes to Cr3+, and iodide ion are oxidized to I2, so we have I2. Now we can see, we can balance this one, 6 Cr6+, so it should be 6. Now chromium is balanced, we have to balance iodine, but for that we need to balance the charges as well. Let's see, we have 6 chromium moles which have +6 charge, so overall positive charge is 36. So we have 36 on one side, and 6 moles of chromium which have got charge of 3+, so it is +18. Now the charge on iodine is 0, So it is only 18 on the product side. In order to make this one 18, we need to subtract 18 from this part. So it means 18 moles of iodide should be there. So if I write 18 over here, now charges are balanced. So 18 moles of iodide can be balanced by writing 9 moles with iodine. 9 2 is 18. Now it says the iodine released, this is the iodine that is released, is reduced back to iodide by X moles of S2O3 to negative ions. Now we can react this one with S2O3 to negative. So we have iodine S2O3 to negative, and iodine release is reduced back to iodide. So product is iodide. And it says 1 mole of iodine is reduced by 2 moles of S2O3 to negative. So they have given the balanced equation. If we have 1 mole of iodine, we already have 1 mole. We need 2 moles of S2O3 to negative. So as we have 9 moles of iodine, so if 1 needs 2, so then 9 mole will need how much? It will be double, so it is 18 moles of S2O3. So what is the value of X? X should be actually 18 moles of S2O3 in order to convert all this iodine to iodide. So therefore answer is D. Question 13. Which statement about acids and bases is always correct? A. An acid with 2 hydrogen atoms per molecule will be stronger than an acid with 1 hydrogen atom per molecule. Now this is not a correct statement because we have carbonic acid H2CO3, which is a weak acid as compared to HCl, which just contains 1 hydrogen atom. So it depends on the dissociation, it does not depend on the number of atoms per molecule. Part B. A concentrated solution of strong acid will have a lower pH than a dilute solution of weak acid. Now pH, it depends on the concentration of H+. So if we have a concentrated solution, then there will be more number of H positive ions and the pH will be lower. And if we have dilute solution means the concentration is now reduced because concentration is inversely proportional to volume. So if volume is increased in dilute solution, then concentration is decreased. So if concentration is decreased, then pH will increase. So this statement seems true. Part C. A concentrated solution of strong base will have lower pH than a dilute solution of weak base. Now let's see, if we have a strong base, then it will have higher pH value because we have more number of OH negative ions. So greater number of OH negative means the pH will be near to 14, which is higher value. So this is wrong. Part D. A strong acid is more dissociated in solution than a strong base. Both are highly dissociated because strong base also dissociates completely while strong acid also dissociates completely. So this statement is wrong. The correct statement is therefore B. Question 14. The reaction between sulfur dioxide and oxygen is reversible. We have this equation given. It is balanced. 2 moles of sulfur dioxide react with 1 mole of oxygen to form 2 moles of sulfur trioxide. Kc is also given as 280 at 1000 Kelvin. In an equilibrium mixture at 1000 Kelvin, the sulfur trioxide concentration is 6 mole per decimeter cube. So it is the concentration of this product. The sulfur dioxide concentration is twice the oxygen concentration as it is given in the equation. What is sulfur dioxide concentration? So you have to find out the sulfur dioxide concentration. So let's suppose if we take oxygen concentration as X, then sulfur dioxide is twice, so SO2 will be 2X. This is the concentration. Concentration is shown in square brackets. Let's suppose if it is like this. Now we can use this value. Let's write Kc. Kc is equal to the concentration of product, which is SO3 raised to the power its number of moles, which is 2, divided by the concentration of reactants. So SO2 squared and O2. Now we already have the values of concentration. Oxygen is X, sulfur dioxide is 2X. So putting these values, Kc is equal to SO3. SO3 is given, it is 6. So 6 squared divided by SO2 is 2X square. Oxygen is X. Kc is also given, it is 280. Now we can solve this equation to find out X. So 280 will be equal to 36 divided by 2x square whole square, it means 4x square. 4x square into x is 4x cube. So now x cube can go over that side, so it will be x cube equals 36 divided by 4 into 280. Now we can take cube root on both sides, and this will give us the value of x. So as x is the concentration of oxygen, it by calculation it comes equal to 0.3179. And concentration of sulfur dioxide is double, so 2x is concentration of SO2. So 2 into this value, it comes equal to 0.636 moles per decimeter cube. So that is the concentration of sulfur dioxide in this question. So correct answer is therefore D. Question 15. The Boltzmann distribution of particles in a mixture of gas X and gas Y is shown in diagram 1. We have the percentage of particles. This shows the hump having maximum number of molecules, and on x-axis we have energy. X and Y react, and the reaction causes an increase in gas molecules present. The reaction goes to completion. In experiment 1, the increase in volume is measured every 10 seconds, so we have the rate of reaction. During the reaction, the temperature and pressure remain constant. Now there is no change in temperature and pressure during the reaction. The increase in volume is shown in the volume time graph in diagram 2. So diagram 1, it shows Boltzmann distribution. Diagram 2, it only shows the increase in volume against time. Okay, let's move further. It says in experiment 2, the experiment is repeated using identical amounts of X and Y. So we have same amount of X and Y. A different temperature is used. Okay, so they haven't given whether temperature is less or more. They just say that it is different. Is used as compared to experiment 1. The same pressure is used. The Boltzmann distribution of second mixture of X and Y is shown in diagram 3. Now from diagram 3 we can find out whether the temperature is less than the previous experiment or more. Now you can see the hump has moved backwards. It has gone backwards and it has risen above. So it means this is low temperature. Because at high temperature the hump moves forward and is lowered, like as given in diagram 1. It is forward and lowered, and at low temperature it moves backward and goes higher, because area under the curve is same as the amount is identical. During the reaction, the temperature and pressure remains constant. Now we are talking about this temperature, which is actually reduced temperature. Which curve on the volume time graph would show the increase in volume against time for experiment 2? Now you have to find out the rate of reaction, because still there is an increase in volume, but what would be the increase in volume compared to the previous experiment? The original line for experiment 1 is redrawn as solid line. So this is experiment 1 that was previously done at higher temperature, and this showed increase in volume. Now we have the same experiment but at lower temperature. So at lower temperature, the rate of reaction also lowers. So this steepness, it shows the rate of reaction. It cannot be A or B because A or B is more steep, so it is faster chemical reaction, while it can be either C or D. Now let's see what is the effect of temperature on volume. We actually know that we can look at the constants. For example, if we have room temperature and pressure, which is 20 degrees centigrade, the volume of gases is 24 decimeter cube, and this is constant. But if we change the temperature to standard temperature and pressure, which is 0 degrees centigrade, so then the volume is reduced to 22.4 decimeter cube. So that shows that when temperature is decreased, the volume also decreases. So if overall volume decreases, then obviously the change in volume should also decrease. In C, we can see the volume is same, or the increase in volume is same as the previous experiment. Now this cannot be true because now we have reduced temperature, so volume should be lower. Correct answer is therefore D. Question number 16. When the temperature of a particular reaction is increased by 10 degrees centigrade, for example 20 to 30, the rate of reaction approximately doubles. What is the most significant reason for this increase? So by increasing temperature, rate of reaction doubles. We can say, let's see, a different mechanism for the reaction. Now temperature does not change the mechanism. It is the catalyst that changes the mechanism. Part B, an increased collision frequency of the reactant molecules. So this is partly true because when temperature is increased, the collision frequency also increases. But we are more concerned about the successful collisions rather than the collision frequencies, because successful collisions can only give you product. Part C, more collisions have energy greater than activation energy. Now this is true because if more collisions have energy more than activation energy, then more product is formed, and when more product is formed, then the rate of reaction will increase and it doubles. So this part is true. A reduced activation energy for the reaction. Now activation energy can only be reduced by catalyst. Let's look into part C a little bit more. Let's suppose A was converting to B, and the energy that was required was actually 10 to convert from A to B, but the molecules, they had energy 1 to 11. Now by increasing temperature, the average energy increased from 6 to 15. Now we can see more molecules have greater energy as compared to 10, so more molecules will convert into product. So product will be higher, and therefore rate of reaction will also be high. So correct answer seems to be part C. Question number 17. Which ion has the smallest radius? Let's see, we have aluminum, we have barium, magnesium and sodium. Now looking at the period number, we have aluminum in 3rd period, barium is in 6th period of the periodic table, magnesium is again in 3rd, sodium is in 3rd. So for neutral atoms, we have 3 shells for aluminum, 6 shells for barium, 3 shells for magnesium and 3 shells for sodium. So it means barium is the largest because it has the greatest number of shells. So it is not barium. Let's see among these 3. So aluminum, the atomic number of aluminum is 13. For magnesium it is 12. For sodium it is 11. So 13 in first shell we have 2 electrons, in second one we have 8 electrons, in third shell we have 3 electrons for neutral aluminum. Now when 3 electrons are lost, it becomes 3 plus and only 2 shells are left, 2 and 8. And the number of protons is still 13. Second one is magnesium. So for neutral magnesium, we have 2 in first shell, 8 in second shell, 2 in third shell. So when it will become Mg2 plus, it will lose 2 electrons. So one shell is lost, we just have 2 shells, and number of protons is still 12. For sodium, Na2, 8 and 1 in third shell, so it will lose 1 electron and 1 shell is lost. So 2 and 8 are left. The number of protons is 11. Now we have similar number of shells, similar number of electrons in shells, but we have different number of protons. So greater protons means greater force of attraction between the nucleus and the electrons. So shells will be closer to the nucleus because of the greater attraction. So therefore aluminum should have the smallest radius. Question number 18, which row is correct? We have elements with higher or with greater fifth ionization energy and element with an amphoteric oxide. So we have to find out whether it is aluminum or phosphorus and whether it is aluminum or both aluminum and phosphorus. So let's see, for this one we need to find out the electronic configuration. Aluminum is 13, phosphorus is 15. So let's do them one by one. Aluminum is 13. So we have 1s2, 2s2, 2p6, 3s2, 3p1. Now in order to remove 5 electrons, because we need to find out the fifth ionization energy, 1 is lost from here, then we have 2, so in total 3 are gone, and 3 and 2 will be gone from here, so 2p4 is left. So we have 1s2, 2s2, 2p4, and 5 electrons are lost. Let's do the second one. We have phosphorus. Phosphorus is 15. 1s2, 2s2, 2p6, 3s2, 3p3. So in order to remove 5 electrons, again we need 3 from this, 2 from this. So 5 electrons are lost. Now p plus 5 will be there. It is equal to 1s2, 2s2, 2p6. Now in both of them we can see the fifth electron is removed from 2p in aluminum, while the fifth electron is removed from 3s in phosphorus. Now 3s is farther from the nucleus as compared to 2p, so the energy needed for 3s should be less as compared to the energy needed for 2p. So greater ionization energy is for aluminum because it is closer to the nucleus. The fifth electron that is removed, it will be closer to the nucleus. Second thing is we have to find out amphoteric oxide. Now aluminum oxide is amphoteric in nature, Al2O3. It can react with acids, it can also react with base. While phosphorus, it is acidic oxide. It is not amphoteric, so it is aluminum only. Correct answer then should be A. Question number 19. Each of the chlorides listed is added to water. We have aluminum chloride, magnesium chloride, silicon tetrachloride, phosphorus pentachloride. Which chlorides form an aqueous solution that reacts with sodium carbonate to produce carbon dioxide? Now we have sodium carbonate. Sodium carbonate is a stronger carbonate, and you should remember that acid plus carbonate, it forms salt water and releases CO2. So it means our aqueous solution must be acidic in nature. Let's see, in the first one is aluminum chloride. Aluminum chloride, when added to water, it forms acidic solution. First, a complex is formed, AlH2O6. We have 3 plus, and then one of the water molecule, it gets ionized to form AlH2O5. OH is left, 2 plus along with H plus. So this H plus, it makes the solution acidic. So part 1 can react with carbonate because it is acidic solution. Second one is magnesium chloride. Magnesium chloride forms magnesium hydroxide along with HCl. So we have both present in solution, magnesium hydroxide as well as HCl. So therefore the acidity will be very less. The pH of this solution is almost neutral. It is equal to about 6.5. So it is not strong enough to release carbon dioxide from sodium carbonate. Let's see the third one. We have silicon tetrachloride, SiCl4. When it is added to water, it forms silicon dioxide, which is solid, along with HCl, which can make the solution aqueous acidic. So again, this is acidic, so it will release CO2 from this carbonate. Then fourth one is phosphorus pentachloride, PCl5, in water. It forms H3PO4 along with the formation of HCl. So this is acidic. So it will also release CO2 from carbonate. So 1, 3 and 4 are correct. So therefore answer should be C. Question number 20. Sodium hydroxide aqueous is added to separate samples of magnesium chloride and barium chloride solutions. Sulfuric acid aqueous is then added slowly to each reaction mixture until it is in excess. What is observed at the end of the reaction sequence? So let's see, if we have magnesium chloride, it forms colorless solution or white precipitate. For barium chloride, it is colorless solution or white precipitate. Let's do the reactions. We have magnesium chloride on one side, barium chloride on the other side. Let's first react them with sodium hydroxide. So magnesium chloride will form sodium chloride, which is soluble, and magnesium hydroxide. Solubility of magnesium hydroxide is less, so it will be in solid form, and this one is white precipitate. For barium chloride, when it reacts with sodium hydroxide, it will again form NaCl, which is soluble, and barium hydroxide. Now as we move down in group 2, what happens? The hydroxide, they become more soluble, so this is soluble. Then it says sulfuric acid aqueous is slowly added to each reaction mixture. Let's do the second reaction. Now we have H2SO4. So it will form magnesium sulfate. Magnesium sulfate is soluble, while this one will form barium sulfate, and down the group the solubility of sulfate decreases, so this one is white solid. Now let's see, at the end of the reaction sequence, magnesium chloride is aqueous, so colorless solution is formed, and at the end of barium chloride reactions, we can see white precipitate is formed. So correct answer should be B. Question 21. A 4 grams sample of an anhydrous group 2 metal nitrate Z is heated strongly until there is no further change of mass. A solid residue of mass 1.37 grams is formed. Which metal is present in Z? We have to find out whether it is barium, calcium, magnesium or strontium. All are group 2 elements. So it says we have metal nitrate. So this could be barium nitrate, BaNO3 twice, calcium nitrate, magnesium nitrate, or strontium nitrate. Let's see what happens when nitrate is heated strongly. So any metal nitrate, when it is heated strongly, it forms metal oxide, nitrogen dioxide, and releases oxygen gas. We can balance this equation. We have 2 moles of nitrogen as nitrogen is 2. Now we have 7 oxygens and 6 oxygens, so we can make this one half. So we are mainly concerned with these two, so it is 1:1. So let's see, 1.37 grams of solid residue. This part is solid, this part is gas, this part is gas. So we can see only metal oxide. This mass is given for metal oxide. Let's find the number of moles for each of them. So let's start from the first one. A 4 gram sample of this one. So if it is 4 grams, let's find the number of moles. So for barium nitrate, first we need to find out the molecular mass. So its MR is calculated and it is equal to 261.3. Now we have to find out the number of moles. Number of moles is mass in grams divided by MR. Mass in grams is 4 divided by 261.3. So number of moles is 0.0153. As the ratio is 1:1, so the number of moles should be same. If it is same, then this is correct answer. If it is different, then it is wrong. So let's do it for metal oxide. Metal oxide means we have barium oxide now. So barium oxide. The molecular mass of barium oxide is calculated. It is 153.3. Mass is given, so now we can find moles. Moles equals mass divided by MR. 1.37 grams divided by 153.3. So number of moles of barium oxide, it comes equal to 0.0089 moles. According to balanced equation, the number of moles should be same as it is 1:1, but we have different moles, 0.0089 and 0.0153. So A is wrong. Let's do the same for B. Now we have calcium nitrate. First, molecular mass. It is calculated and is equal to 164.1. Then we have moles. 4 grams divided by 164.1. It is equal to 0.0244 moles. Now let's do the same for calcium oxide, which should be one of the product. So calcium oxide MR is equal to 56.1. Mass given is 1.37 grams. So 1.37 divided by 56.1. It is equal to 0.0244. So this is according to the balanced equation. Both moles are same as is in this equation, 1:1 ratio. So therefore barium seems to be correct. Answer is therefore B. Question 22. Chlorine is bubbled through a cylinder containing aqueous sodium iodide and an immiscible layer of hexane. As the bubbles pass through the cylinder, what is observed in the lower and upper layers? In lower layer we have aqueous sodium iodide, while in upper layer we have hexane, and this is a chlorine gas that is bubbled in lower layer first and then it goes in the upper layer. Excess gas goes out from this part. Now we have to find out the color change in lower aqueous layer and the color change in upper hexane layer. So let's see what happens when chlorine is added to aqueous sodium iodide. Sodium iodide is NaI. So when chlorine is added, now chlorine can replace iodine because it is more reactive, so it will become sodium chloride and iodine is then released. Now the color of iodine is brown. It means that brown iodine is going to be formed here. Then this iodine can also dissolve in this layer. So we have hexane layer. So in lower aqueous layer, colorless solution becomes brown. This is because iodine is being produced. And then in upper hexane layer, the colorless liquid becomes colored. So when iodine goes and dissolves in hexane, again this hexane is also going to be colored. So correct answer is then A. Question number 23. Chlorine and bromine have different volatilities. Which row identifies the more volatile of the two elements and gives the correct explanation? We have bromine and chlorine. Now let's see, in group 7 of the periodic table we have fluorine, chlorine, bromine and iodine. Now fluorine and chlorine is in the form of gas, bromine is low boiling liquid and iodine is solid. So we can see that down the group volatility decreases. So bromine is less volatile as compared to chlorine. So more volatile will be chlorine. Let's look at the reason. For explanation, it says intermolecular forces are greater in bromine or intermolecular forces are greater in chlorine. So as we move down the group, the boiling point or melting point increases. This is because intermolecular force increase. And size of atom also increases. So stronger forces are present in bromine as compared to chlorine. The intermolecular forces are greater in bromine. So this should be correct and this is wrong. Correct answer is therefore C. Question number 24. Ammonium chloride dissolves readily in water. Which statement about the colorless solution formed is correct? Part A. Ions in solution can form hydrogen bonds with water molecules. Let's see what is formed when ammonium chloride is dissolved. NH4Cl. It dissolves in water to form ammonium ions and chloride ions. Now it says hydrogen bonding can form. Now in ammonium ion we have nitrogen that is attached to hydrogen atoms. In water we also have hydrogen attached with oxygen. So for hydrogen bonding we know we must have fluorine, oxygen or nitrogen, either of these elements directly attached with water. So we do have nitrogen attached with hydrogen. Nitrogen is more electronegative, so it is partial negative. Hydrogen is partial positive. Similarly, oxygen is partial negative and hydrogen is partial positive. So what will happen? The hydrogen of water molecule, it will be attracted to nitrogen of ammonium, and hydrogen of ammonium, it is going to be attracted by oxygen of water molecule. So this will form hydrogen bonding. So part A seems to be correct. B. The solution is slightly basic. Now in solution we have ammonium ions, we have chloride ions. So the ions, they do not make solution acidic or basic. So this is wrong. Part C. The solution would smell of chlorine. Now chlorine is not in Cl2 form, it is in chloride form. So chloride is soluble, it does not smell. Part D. When sodium hydroxide is added, a gas is formed which turns damp blue litmus paper red. Now we have ammonium salt, and we know whenever a base or alkali is added to ammonium salt, what happens? It forms salt water and releases ammonia gas. Now this ammonia gas that is released, it is basic in nature. So basic gas turns red litmus paper to blue. It does not turn blue litmus paper to red. So D is also wrong. Correct answer is therefore A. Question 25. At 550 degrees centigrade, nitrogen dioxide reacts with unburnt hydrocarbon fragments such as CH3 in the catalytic converter of a motor vehicle. So catalytic converter, it provides activation energy, and this CH3 it converts into CO2 and H2O. Which row gives the energy change for this reaction and a possible reason for it? Now, as we can see, hydrocarbons are being converted to carbon dioxide and water. This happens when we have combustion. And combustion is usually exothermic in nature. So therefore, we can see that the reaction should be exothermic. Now let's look at the reasons why it is exothermic. So we have CO2 and H2O have negative enthalpy change of formation values, and double bonds are broken in NO2. Let's see this one. Let's suppose we have this CH3NO2. It forms nitrogen, CO2 and water. Now the elements involved are carbon, nitrogen, oxygen and hydrogen. They can make this and they can also form this. So we have enthalpy change of formation of CH3 and NO2. We have enthalpy change of formation of nitrogen, carbon dioxide and water. Let's suppose it is 1, this is 2, and this is enthalpy change of reaction. Now we know that enthalpy change of this reaction is exothermic, so it is negative. So by Hess's law, del HR plus del HF1, it is equal to del HF2. In order for this one to be negative or exothermic, this part must be negative. And if this part is negative, it will move over there and it will become positive value. So delta HR, it is equal to del HF2 minus del HF1. Now del HF2 must be negative and it should be greater than del H1. Only then enthalpy change of this reaction will be negative. If del HF2 is positive, then this reaction might be endothermic in nature, which is wrong. It is exothermic. So in del HF2 we can see we have enthalpy change of formation of CO2. We also have enthalpy change of formation of H2O. Del HF2 is negative, then it means these two must be negative. Second reason is double bonds are broken in NO2. NO2 is the reactant, and whenever the bonds are broken in reactant, the reaction is endothermic. So bond breaking is endothermic. This is not the correct reason. Now looking at the other two, we can see for endothermic it says chemical energy is converted to heat energy. Whenever chemical energy is converted to heat energy, it means energy is released in the form of heat, and this is a reason for exothermic. It is not a reason for endothermic. So this is wrong. Then it says the nitrogen triple bond energy is very high. Now nitrogen triple bond is being formed in the product. So whenever bond is formed, it is exothermic in nature. So this is also a reason for exothermic, which is incorrect because they have given this one as endothermic. So the only possible answer is C. Question 26. Compound X contains an alcohol group and a carbonyl group. This is compound X. Which row is correct? You have to find out the type of alcohol group, whether it is primary or tertiary, and the type of carbonyl group, whether it is aldehyde or ketone. Now in primary alcohol we have OH attached to carbon atom that is directly attached to just one carbon atom. While in this one we can see the OH group, it is attached to carbon atom which is directly attached to 3 other carbon atoms. So this is not primary, it is tertiary. Now let's look at the type of carbonyl group. We have C double bond O, which is carbonyl carbon, and this carbon is attached to 2 carbon atoms directly. So whenever we have a formula like this, C double bond O, and on both sides we have carbon, then this is a ketone. If we have hydrogen on one side and carbon on the other, or both sides, if both sides are hydrogen, then it is aldehyde. So this one is ketone, and the answer is therefore D. Question 27. The diagram shows the skeletal formula of phenazine. This is the skeletal formula. What is the empirical formula of phenazine? The empirical formula, it shows the simplest ratio of atoms. So let's see how many carbons are there. We have 1, 2, 3, 4, 5, 6, and then again we have 6 in this ring structure. So in total we have 12 carbon atoms. So I can write C12. Now let's find how many hydrogens are there. This carbon is making 4 bonds. So no hydrogen. This is making 3 bonds. So 1 hydrogen, 1, 1, 1. So we have 4 hydrogens on this side. Similarly, these 2 carbons are making 4 bonds each. So no hydrogen is with them. 1, 2, 3, 4. So 4 and 4 becomes 8. So we have 8 hydrogen atoms and 2 nitrogen atoms in the center. Now we can find out the simple ratio between these 3. So 2, 8 and 12. So it will become C6H4N1. So C6H4N is the empirical formula. Question 28. The diagram shows the structural formula of mevalonic acid. This is mevalonic acid. We can see we have carboxylic acid, we have alcohol group, we have CH3, and we have another alcohol group. Which reagents and condition will react with mevalonic acid to produce an organic compound without a chiral carbon atom? Now let's see which carbon makes this one chiral. So chiral carbon means the carbon that is attached to 4 different groups and no double bond is present. This carbon is making double bond with oxygen in carboxylic acid, so it is not chiral. This carbon is attached to similar atoms, so it is not chiral. This carbon is attached to OH, CH3, this alcohol group, and this carboxylic acid group, so this is chiral carbon. This carbon is not chiral, it has 2 same hydrogen atoms, similar is for this carbon. So we need to find out or make such a product in which this carbon becomes non-chiral. Let's see, first one, it says heat under reflux with CH3OH. So this is alcohol, and alcohol can react with acid to form ester. So this acid part will react and it will form ester. Let me rewrite this one. So we have C double bond O, OH, then we have CH2, then chiral carbon, OH and CH3, then again CH2, CH2 and OH. Now with A, what will happen? This part will make ester. So the product will be like this. We have methanol, 1 carbon, alcohol, so it will form CH3O, C double bond O, and rest is the same. Still we can see that this carbon is attached to 4 different groups. This side is different to this one. So chiral carbon is still present. So this is wrong. Part B, it says heat under reflux with potassium dichromate in the presence of acid. So what does dichromate do? It oxidizes the compound. So So in this one we have tertiary alcohol. Tertiary alcohol is not oxidized further, but primary alcohol is oxidized. So this CH2OH, it is primary alcohol, it can be oxidized to carboxylic acid. Then after oxidation the structure will be like this. We have COOH on this side, then CH2 and chiral carbon, then CH2 and another carboxylic acid. Now we can see this side is similar to this side, so therefore this carbon is not chiral anymore. So the product is without a chiral carbon atom, so this could be correct option. Let's see what happens with sodium at room temperature. Now sodium can react with alcohol whether it is tertiary or primary, so it will and sodium can also react with carboxylic acid. So we can have sodium Na positive, O negative, and then CH2, carbon having O negative, Na positive, CH3, then CH2, CH2, O negative and Na positive. Now we can see still 4 groups attached with this carbon are different, so it is still chiral. Last one is PCl5 at room temperature. Now what PCl5 can do is it can replace OH. The product will be like this. We have OH replaced. This OH is also going to get replaced. So we have COOH, CH2. Now chlorine is present instead of OH. And again chlorine is present instead of OH. So all 4 groups are still different, so still we have chiral carbon. Correct answer is therefore B. Question 29. Structural isomerism and stereoisomerism should be considered when answering this question. In structural we have different length of chains, in stereo we have cistrons. Y is a gaseous hydrocarbon which decolorizes aqueous bromine. Now this information, it gives us that Y could be alkene, because bromine adds up in double bond of alkene to make itself decolorized. Then we have 10 grams of Y that occupies a volume of 3.43 decimeter cube. So this is the volume under room conditions. How many isomeric structures are possible for Y? So let's try this one. First we have to find out the molecular mass and the structure of alkene. So the information given is the volume and mass. From volume we can find out the number of moles, as moles equals volume in decimeter cube divided by 24 decimeter cube. So 3.43 divided by 24, it is equal to 0.143 moles. So this much moles of Y is present. Now we do have mass, so from moles and mass we can find molecular mass, as moles equals mass in grams divided by mR, or mR is equal to mass in grams divided by number of moles. So we have 10 grams, we have 0.143 moles, so the molecular mass, it comes equal to 70. So now let's see which alkene is making mR equal to 70. We have different alkenes. For example, the general formula is CnH2n. So for 2 carbons we have 4 hydrogens, for 3 carbons we have 6 hydrogens, similarly 8 for 4 and 10 for 5. Molecular mass 12,2 is 24 plus 4 28, so it is wrong. 12,3 is 36 plus 6 42, it is incorrect. 48 plus 8 is 56, this is also wrong. 60 plus 7 is 70, so this one is correct. It means that Y is C5H10, which is pentene. Now it says how many isomeric structures are possible for Y. Let's draw isomeric structures. The first one, we have 1, 2, 3, 4, 5. So this is pent 1-ene, and with double bonded carbon we have similar hydrogen atoms, so only one isomer is possible. The trans isomer is not possible. Then we can change the long chain. The long chain was of 1, 2, 3, 4, 5 carbon. Now we can make it 4. 1, 2, 3, 4. The fifth carbon can be attached over here. So this is the second isomer that is possible, and still cis trans is not possible because double bonded carbon has similar atoms. Let's see what if I can take this carbon to this carbon. So the long chain is still of 4, and now we have a carbon atom on this carbon. So still no cis trans is possible, so overall we have 3 isomers up till now. Now let's change the position of double bond. We can shift double bond to a previous carbon. So instead of the last one, we can have second last one. 1, 2, 3, 4, 5. Now let's see, this carbon atom is attached to a hydrogen atom. It is also attached to a hydrogen and CH3. So both double bonded carbons have different groups attached, so therefore it will show cis and trans. So fourth one is cis and fifth one is trans. So now we have 5 isomers overall. Let's try to attach this carbon to this carbon atom. So we can have C double bond C, hydrogen atom, and CH3, and CH3 and CH3. Now we can say that double bonded carbon is attached to similar groups. So cis trans is not possible, but this is one of the isomers. So 1, 2, 3, 4, 5, and 6. So overall 6 isomers are possible for Y. So answer should be C. Question number 30. Limonene is found in lemon and orange oils. This is the structure. We have double bond over here. We have a double bond over here. So it is alkene. What is the major product when limonene reacts with excess of dry HCl? Now for this one, you should remember that whenever a halogenoalkane is formed from alkene, hydrogen atom attaches to carbon atom of double bond having more hydrogen atoms. And the other part, chlorine, it will be attached to the other carbon which has less number of hydrogen atoms. Let's find out the number of hydrogen atoms in this structure. We can see we have this carbon that is making a double bond, so it has 0 hydrogens because it is attached to 2 carbons and making a double bond. This carbon is attached to 1 hydrogen atoms. So it means that the incoming hydrogen will be attached to this carbon and chlorine is going to be attached to this carbon. So product will be like this. Let's convert double bonds to single bonds, and then incoming hydrogen is gonna get attached to this carbon and chlorine is attached to this carbon. Similarly, between these 2 carbon atoms, we can see this carbon has 2 hydrogen atoms while this one has 0. So it means hydrogen will be attached to this carbon and chlorine is going to be attached to this carbon. So this is the major product that is formed. Let's compare our product with the answers given. So Cl is in correct place, hydrogen is not shown in the skeletal formula, and Cl is not here. Cl is in the wrong place, Cl is in correct place, Cl is in correct place, Cl is wrong, Cl is wrong. So correct answer is then C. Question 31. Which statement concerning the hydrolysis of 1-bromopropane with water is correct? Let's draw the structure of 1-bromopropane. We have 3 carbon atoms in propane. On first carbon atom, bromine is attached. Rest are the number of hydrogen atoms. So it is 2, this one is 2, this one is 3. Part A. The hydrolysis between water and 1-iodopropane is faster because the carbon-bromine bond is less polar than carbon-iodine bond. Now in iodopropane we have iodine instead of bromine. So carbon-iodine bond is weaker as compared to carbon-bromine bond, so it will be faster. And the reason given is that the carbon-bromine bond is less polar. Now this is incorrect because bromine is more electronegative. So more electronegative means there is more polarity in this bond, while less electronegative means that there is less polarity in this bond. So A is wrong. Part B. The hydrolysis reaction with water is very slow because water is a weak electrophile. Now let's see what happens when it reacts with water. On the water it gives OH negative, and that OH negative can then attack on this partial positive carbon atom to remove this bromine. Now this is negative OH, so it is nucleophile. It is not electrophile. This part is nucleophile. Part C. The mechanism of the reaction involves the formation of a stable carbocation. Now stable carbocation formation, it takes place in tertiary halogenoalkanes. Tertiary is the one in which halogen is attached to the carbon, and that carbon is attached directly to 3 other carbon atoms. While in this one we can see the carbon attached with halogen is just attached to 1 carbon atom, so this is primary halogenoalkane. And in primary halogenoalkane the stable carbocation intermediate does not form. So this is also wrong. Next we have part D. The reaction is slower with 1-chloropropane because the carbon-chlorine bond is stronger than carbon-bromine bond. Now if you compare this one with 1-chloropropane in which we have carbon-chlorine, the rest is the same. So as chlorine is more electronegative, carbon-chlorine bond is more stronger bond, so stronger bonds needs more energy to break. This bond is weak, so this reaction will be fast and this reaction will be slow. So part D seems to be correct. Now what will happen, that OH negative, it will replace this Br to form alcohol. Correct answer is therefore D. Question 32. Compound J, we have C15H23Br2Cl is reacted with an excess of hot concentrated solution of sodium hydroxide in ethanol. One of the products is X. What could be the skeletal formula of X? For this one you should remember that sodium hydroxide in ethanol, it causes elimination. Now elimination of hydrogen along with 1 bromine or the halogen, it takes place. So hydrogen is removed alongside with halogen. And then we have a carbon-carbon double bond that is formed. So after elimination, alkene is formed. Now we can see in this structure we have this halogen bromine, then we have this halogen chlorine, this halogen is bromine. So let's see whether we have adjacent hydrogen atoms on adjacent carbon or not. So for this carbon on which bromine is attached, the adjacent carbon is this one, and this carbon is already making 4 bonds, so there is no hydrogen attached. So therefore elimination cannot occur between these 2 carbon atoms. Instead, we can see this carbon atom has two hydrogen atoms directly attached. So what will happen? The bromine, it will be removed from this carbon, and one hydrogen atom is removed from this carbon, and there will be a double bond between these two carbons. So in product we have a double bond here. Now looking on the second part, we can see this carbon that has chlorine, it does not have any hydrogen atom. But this carbon has again got two hydrogen atoms. So one hydrogen atom will be removed with one chlorine, so there will be a double bond between these two carbons. So there is going to be a double bond here. Chlorine is lost. Now this bromine, we can see this bromine, it cannot go with this carbon because this carbon does not have any hydrogen, but this carbon has got two hydrogen atoms. So one hydrogen is lost with one bromine and double bond will be here. Now we have one double bond over here. So this is the product that is formed after elimination. Let's look into the given answers. We have double bond in this position, a double bond in this position, and this. So A seems to be correct. In B we can see double bond is here, which is not possible. In C again it is not possible. In D it is in correct place. Now we can see there is a double bond between these two carbon atoms. This can happen if this chlorine, it takes a hydrogen atom from this carbon. So there will be a double bond here, but still another double bond is to be made between this bromine and this hydrogen. So there should be two double bonds shown. One double bond is not possible. So correct answer is therefore A. Question 33. Structural isomerism only should be considered when answering this question. Several compounds with molecular formula C4H8O2 have one carbonyl group and one OH group. How many of these compounds produce yellow crystals with alkaline iodine aqueous at room temperature? Now we know for alkaline aqueous iodine, we need to have CH3 directly bonded to any carbonyl carbon, or CH3 directly bonded to carbon having OH. This should be secondary alcohol. This can be a ketone or an aldehyde. So let's see which product does have this. So we have C4H8O2 and one carbonyl group and one OH group. So in total we have 4 carbon atoms. Let's draw the possible structures. So 1, 2, 3, 4. Now let's suppose this is CH3, this one is also CH3, and this carbon contains a carbonyl group and this carbon contains an OH group. So now we can see we have CH3C double bond O ketone, and we also have secondary alcohol. So this is the possible structure. Let's see whether we have any other possibility. So if we maintain this part CH3C double bond O, but we shift OH to the last carbon. Now alcohol will not give a yellow precipitate, but this part will still give a precipitate as it is methyl ketone. So now 2 are done. And in third one we can not change this part, but we can change this part. So let's see. In third one we have OH on second carbon. And carbonyl is on last one. So one part is aldehyde, but it does not have any CH3 group directly attached, while second part is secondary alcohol having CH3 directly attached. So this will also give positive result with alkaline aqueous iodine. The molecular formula of all these three is we have 4 carbons, 8 hydrogens and 2 oxygens. So only these three are possible structures, because if you change the position of this OH, then it will not give result with this alkaline aqueous iodine. So correct answer is then B, 3 structures. Question 34. Pentaerythritol is used as an intermediate in the manufacture of paint. This is a structure. We have 4 OH groups present on 4 corner carbons and there is 1 carbon in the center. Which statement is correct? Pentaerythritol can be dehydrated by concentrated sulfuric acid to form an alkene. Now concentrated sulfuric acid is dehydrating agent. It can remove water from compounds, from alcohols. Now it happens if one of the carbon has OH and the adjacent carbon has got a hydrogen atom. So what will happen? This OH is removed along with this hydrogen and an alkene will be formed. So let's see if we can look at the structure. OH is attached to this carbon. And the adjacent carbon for this carbon is this one. So this carbon does not have any hydrogen atom. Similarly, this is adjacent to this carbon or this one. So OH cannot be removed because we do not have any adjacent hydrogen atom. So therefore dehydration will not occur. Part B, the empirical formula and the molecular formula of pentaerythritol are different. Let's find out the empirical and molecular formula. We have 5 carbons, 12 hydrogens, and we have 4 oxygen atoms. Let's find out the empirical formula. As we have an odd number, so therefore empirical formula is also going to be same. So this is wrong, it is same. Pentaerythritol does not react with acidified potassium manganate 7. Now acidified KMnO4 7 is actually oxidizing agent, and it can change primary alcohol to carboxylic acid. So as all of them are primary alcohol, so therefore 4 carboxylic acid functional groups will be formed. The result is like this. We have COOH, 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 and then 4th carboxylic acid. So it will react. Part D, 1 mole of pentaerythritol gives 2 moles of hydrogen gas on reaction with an excess of sodium. Let's react this part with sodium. Now sodium can react with alcohol to form alkoxide along with the release of hydrogen gas. Plus now we have excess sodium. So instead of this hydrogen atom is replaced by sodium, and we have Na positive attached. Now we can see 4 hydrogen atoms are lost. So if we write in terms of hydrogen molecule, then we can balance by writing 2. So then it will become 4 atoms. So we can see 2 moles of hydrogen gas are released. So this part is correct. Answer is therefore D. Question number 35. Which reaction has a nucleophilic addition mechanism and gives a good yield of product under the standard conditions? A. 1-bromopropane reacting with hot ethanolic sodium hydroxide. Let's see whether this is nucleophilic addition or something else. Now if we have halogenoalkane and if you have ethanolic sodium hydroxide, what will happen? It will cause elimination reaction and an alkene is formed. So this is not nucleophilic addition, it is wrong. Part 2, 2-iodopropane reacting with hot aqueous sodium hydroxide. When we have aqueous sodium hydroxide, it means that OH negative, it will replace this iodine. So this is substitution reaction, nucleophilic substitution. So again this is incorrect. Part C, propanol, which is aldehyde reacting with hydrogen cyanide under alkaline conditions. And part D is same, only the conditions are different, it is acidic conditions. Let's see what happens when propanol reacts with hydrogen cyanide under alkaline conditions. So we have hydrogen cyanide. Hydrogen cyanide is HCN. It can react under alkaline conditions. Alkaline means we have OH negative. So what will happen? This OH negative, it will abstract a proton to make water and Cn negative is formed. Now this Cn negative, it is a nucleophile. So let's see how it reacts with propanol. Propanol means we have 3 carbon and it is an aldehyde, so CH3, CH2, C double bond OH. What will happen is that this Cn, it is going to attack this partial positive carbon and the bonded electrons, pi electrons, it will shift to this oxygen. So we have CH3, CH2. Then with this carbon, Cn will be attached, hydrogen is already there, and this oxygen will become negative. Now this oxygen, it can take hydrogen atom from HCN. If we have HCN, so the product is CH3, CH2, CH, Cn and OH. So what we can see is that a hydrogen atom is attached, a Cn is also attached. So this is basically addition reaction and Cn negative is reformed as the product. So as this part is nucleophile, so this is nucleophilic addition. So propanol reacting with hydrogen cyanide under alkaline conditions is nucleophilic addition. So C is correct. In part D we have acidic conditions, so acidic conditions cannot take out proton from HCN, so the reaction will not occur. So correct answer is C. Question 36. A carbonyl compound has the structural formula CH3COCHO. Which row is correct for the observations made when this compound is treated with the given reagents? First thing is 2,4-D-NPH. Second thing is the Phalens reagent. Now 2,4-D-NPH, it can give positive results with aldehyde and with ketone. While Phalens reagent, it can only give positive results with aldehyde. Let's see, what do we have here? We have CH3, then we have C double bond O, and we have CHO, which is C double bond OH. Now we can see we have a ketone and we also have an aldehyde. So ketone and aldehyde give positive result with 2,4-D-NPH and it gives orange precipitate. While Phelan's reagent, it only reacts with aldehyde and red precipitate is formed. If we had Tollens reagent, it will make silver mirror. So correct answer for the observation is D. Question 37, an ester is shown. This is the structure of ester. We can see we have this functional group C double bond OO. Which two compounds react to form this ester? We can find out the two compounds that make ester, which are usually carboxylic acid and alcohol, by breaking this carbon-oxygen bond. So the part having carbonyl carbon is the one that comes from acid, while the other part it comes from alcohol. So the acid part is CH3, CH2, COOH. Second part is alcohol, so we have OH, which is attached to this carbon, and it is attached to 3 CH3s. So we have 3 carbon carboxylic acid, which is propanoic acid. Let's look into the given answers. We have propanoic acid, this is methyl propanoic, and this is ethanoic. So among first and second, let's find out which alcohol do we have. So first thing is, in naming, you have to find out the long chain. So we have 3 carbon atoms present in the long chain, and these two are the substituents. So we can number it 1, 2, 3. So on second carbon we have alcohol, on second carbon we also have methyl group. So it is 2 methyl. In long chain we have 3 carbon atoms, so it is propane. And on second carbon we have alcohol, so it is 2-ol. So 2 methyl propane 2-ol is this one, therefore answer is B. Question 38, which compound can be used to make propanoic acid by treatment with a single reagent? First one is alkenes, second one is cyanide, third one is alcohol as well as cyanide, fourth one is secondary alcohol. So let's see, first one is alkene. Now we can break the bond of alkene. For example, CH2 double bond CH, CH2, CH3. For this one, if we use hot concentrated KMnO4, it will break this double bond and it will convert rest of the products. If the carbon having double bond and 2 hydrogen atoms, it goes to CO2, while the carbon having 1 hydrogen atom and a double bond and 1 carbon atom directly attached goes to carboxylic acid. So we have 3 carbon carboxylic acid, CH3, CH2, COOH. So now we can see a propanoic acid is formed and we have just used a single reagent. So part 1 is true. Now part B, it says CH3, CH2, CH2, CN. We have cyanide. If we do acid hydrolysis of cyanide, what happens, it breaks carbon nitrogen bond and it converts the carbon atoms into carboxylic acid. But we have 4 carbon atoms here, so therefore in acid reflux there will be 4 carbon carboxylic acid that is formed, along with the salt of nitrogen, which is ammonium salt. So this is butanoic acid, it is not propanoic acid. In C, we can see we have secondary alcohol, we also have a CN. Structure is like this, CH3, CH, then we have an OH and CN. Now again we can make this into carboxylic acid, but this part is oxidized to ketone, it cannot form carboxylic acid. So if we are going to make carboxylic acid, it will also contain OH group on second carbon. So in acid reflux, it will form propanoic acid having alcohol group on second carbon. Now we have D. This one can be oxidized to ketone. It will not form carboxylic acid. So correct answer is then A. Question 39. A sample of sulfur consists mostly of 32S. It also contains 4.2% 34S and 2.8% 36S. No other isotopes of sulfur are present. What is the relative atomic mass of this sample of sulfur? For this one we can use formula. We have atomic mass. It is equal to AR of first isotope, atomic mass of isotope into its percentage abundance. This is for first isotope, plus atomic mass into percentage abundance of second isotope, and so on, divided by the sum of percentage abundances. Let's find out the percentage abundance of all. Now we only have 3, no other isotope is present, so percentage can be found out for this one. If we have 4.2% for this, 2.8% for this one, so we can subtract them from 100 to find out the percentage abundance of this. So we'll have 100 minus 4.2% plus 2.8%. So it comes equal to 93. So it means the percentage abundance of S32 is 93%. Now we have percentage abundance and atomic masses of all 3 isotopes, so we can use this formula. The sum of percentage abundance is 93 plus 4.2 plus 2.8, which is equal to 100%. So AR is equal to, for the first one we have 32 into 93. For second one we have 34 into 4.2. Similarly for third one we have 36 into 2.8. Divided by the sum, which is 100. So this gives us the atomic mass. It is 32.2. So correct answer is therefore B. Question 40. One molecule of an addition polymer containing 2000 repeat units has a molecular mass of 112,000. The polymer molecule contains chiral centers. What is possible monomer for this polymer? Okay, now remember that these are the monomers, and in polymer the number of atoms does not change. Only the double bond is converted into single bond. So number of atoms in this one is, we have 3 carbons, we have 6 hydrogens. So we can find out the molecular mass for this one. 12, 3 is 36, 36 plus 6 is 42. So as we have 2000 repeat units, so if this is repeating 2000 times, so we can multiply it with 2000. The molecular mass will be 84,000 for polymer. But it should be 112, so this is wrong. For second one, let's do the same. Number of carbon atoms is 4 and hydrogen atom is 8. So 12, 4 is 48 plus 8 is 56. So it comes equal to 112,000. So this could be correct. Let's see the third one. We have 1, 2, 3, 4. Again 4 carbons, 8 hydrogens. So MR is going to be same, 56 into 2000 is 112,000. So it could also be C. Let's look into D. We have 1, 2, 3, 4, 5 carbons, as it is alkene, so it is C5H10. So 12, 5 is 60 plus 10 is 70. Into 2000 units, so it is 140,000. So correct option could be any one of B or C. Now we have the other point which says the polymer molecule contains chiral centers. Now chiral centers is the one in which carbon atom is attached to 4 different groups. So let's find out the polymer for B and for C. So for B, we have CH2, double bond, C, and we have 2 CH3 groups. So only those carbon atoms that are part of double bond, they are shown in the backbone of polymer, not the side carbons. So what will happen? This electron, it will move to left side, one of the electron will move to the right side, and we have 2 new bonds that are formed. Rest is same. Now this is one part of the polymer chain. So we can see both these carbons, they have got similar atoms attached. So it means none of them is chiral. So it is not B. Let's look into C. We have CH2, double bond C. We have a hydrogen and we have these 2 carbons. So this is monomer structure. Same thing will happen. This bond will break. One electron goes on left side to make a new bond. One electron goes on right side to make a new bond. Rest of the structure is same. We have C having 2 hydrogen atoms. So this is not chiral carbon. This carbon contains a hydrogen atom and CH2CH3 group. So we can see these 2 are different, and left and right side can be different because it can be at any position in the polymer. So therefore this carbon is chiral carbon. So correct answer is therefore C. Thanks for watching. If this was useful, please do like, subscribe and share.